Welcome all. My topic for seminar is particle reinforced composites. So first of all, let us see what are composites. The composites are physical mixture of two or more materials that are chemically different and separated by a distant interface. They are broadly classified into particle reinforced composites and fiber reinforced composites. So let us talk about particle reinforced composites. They consist of particles of one material being reinforced in the matrix of a second material to increase its mechanical strength. The particle reinforced composites are mainly divided into large particle composites and dispersion strengthened composites, which is based on the strengthening mechanism. Now let us see deeper into large particle composites. The large particle reinforced composites, let us take an example of concrete. We all know that the concrete is a mixture of cement, sand and gravel, where the cement takes the matrix form, sand, gravel is the particulate form which is being added or reinforced into the matrix form. And let us see the properties of these large particle reinforced composites. The first one is the particle matrix interaction is treated in macroscopic level, and the particle size is between 1 to 50 micrometer, and the concentration is about 15 to 40% of the volume. As we have seen the above example of concrete, the cement as the matrix and the particles is added as sand and gravel, which takes the concentration 15 to 40% of the volume, and particulate phase is more stronger and stiffer than the matrix. Let us see that above example in which we have the sand and gravel, which is more stronger and stiffer than the cement, which takes the matrix form. And next point is matrix phase transfers the stress to the particles and which bears fraction of the load. And we know that after reinforcement, the matrix bears more load than before reinforcement. It transfers the stress to the particles. So the next point is degree of reinforcement depends upon the volume fraction and strength of bonding between the particle and the matrix phase at interface. We can see take the above example, just the concrete. There the degree of reinforcement depends on the volume fraction which the particles is being added. More particles is being added, there is more degree of reinforcement, and the strength of bonding between the particles and the matrix phase, which also increases the degree of reinforcement. And the next point is the particle reinforcing must be of same size. We have taken the example of concrete. Yes, the particles are sand and gravel, so these particles may be approximately of the same size or approximately about same size for more reinforcement. Now let us take an example which is cements, which is a composite of ceramic particles which is strong and brittle in a metal matrix which is soft and ductile. Okay, here the matrix is the metal and we have the particles for reinforcing is the ceramic particles which must be strong and brittle. Which is used for enhancing the toughness of the material. Now let's take an example, the tungsten carbide and titanium carbide ceramics in cobalt and nickel. Here the ceramic particles, that is the particle being reinforced, is tungsten carbide and titanium carbide, and the matrix metal used is cobalt and nickel. And this cermex is used mainly for cutting tools of hardened steels. Another example is vulcanized rubber. Vulcanized rubber is a material that undergoes a chemical process known as vulcanization. And during this process, the natural rubber is being added with sulfur and other curatives, and which is being heated to a specific temperature, which is also known as reinforced rubber. And this is mainly done for improving its elasticity, tensile strength, etc. And this is obtained by strengthening with 20 to 50 nanometer carbon black particles. They are mainly used in automobile tires. Another classification of particle reinforced composites is dispersion strengthened composites. So let us see its properties. which mainly uses uniformly dispersed fine and inert particles for reinforcement. And the particle size is with diameter 10 to 100 nanometer. When comparing with large particle reinforced composites, the particle size is much smaller. And the particle matrix interaction is at atomic or molecular level. We have already seen for large particle reinforced composites, which was at macroscopic level. And the volume fraction is between 15 to 40%, which mainly consists of metals, non-metals and semi-metals. And the matrix is the load bearing phase. We have seen for large particle reinforced composites in which the particle was the load bearing phase, and here the matrix is the load bearing phase. And matrix is strengthening by impeding motion of dislocation or by interaction between the dispoids and the matrix. So it is being strengthened by the dislocation motions and also the interaction between the dispoids, that is the particles being dispoids in the matrix. And the strengthening depends upon the size of the particles and intermolecular spacing. And the strengthening is happened at elevated temperature for extended period of time. That is, it is being strengthened by giving a high temperature for a long period of time. So by that I'm concluding my portion for seminar, and thank you all.